its base support. So the tower, even though it is leaning downward, it is still in stable equilibrium. Okay, this is another example. When you're doing your exercise, the body of this guy is leaning forward, macam nak tumbang, but actually, since the center of gravity is here, the weight, when you exercise, you make sure that your body is in equilibrium. This guy must be really fit, because he does not fall when he do this. Okay, so he is actually in equilibrium because the total weight of his body concentrate on the center of gravity, which is here. Okay, locating the center of mass of a symmetrical object. If a homogeneous object has a geometric center, that is where the center of mass is located. Okay, this is a cube. The center of mass is really at its center. Same with all other objects, sphere, cylinder. The center of mass is usually all the times at its center point. Okay. If an object has an axis of symmetry is this line. For example, we have the this. It has axis of symmetry here. The center of mass lies along it. Okay, the center of mass lies along the axis of symmetry. So, for example, we have donut. Even though if we have a ring donut with a hollow at the center, since donut has axis of symmetry, the center of gravity does not lie on the donut itself, but at its center. Okay, at its center. Okay, let's see if we want to find the center of mass of the system of the particle shown here. Here we have three particles, M1, M2, and M3. So we want to find the X bar of all the particles. Here we have M1, X1 plus M2, X2 divided by M1 plus M2. Okay, by right, we should have X bar is equal to M1 X1 plus M2 X2 plus M3 X3, because altogether there are three particles, divided by the total mass, which is M1 plus M2 plus M3. Okay, so now why in this formula here, in this solution, it doesn't include X3? This is because the particle M3 now falls on the y-axis. Okay, let me show this. Okay, this is the y-axis, When the particle is really on the y-axis, now see the x. The x on y-axis is 0, right? Okay, so here x is 0. X is 0. Okay, x is 0. Therefore, when we put x3 for particle 3, 0, altogether here will be 0. This one, okay, will end up be 0. Therefore, we only have m1 x1 plus m2 x2. From the formula, this is from the formula x bar equal to summation. Now I insert the symbol okay, summation of m I x I divided by summation of mi. Okay. So when m3 x3 equal to 0, we don't take into account the m3. The x bar now comes from m1 x1 plus m2 x2 divided by summation of mi. Okay, that's how we do it. Okay, now let's see if we want to find the y bar, yeah? Y bar. Y bar. Y bar is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Okay, now m1 first. Let's see m1. M1 and M2, the location of these two particles are exactly on the x-axis. Okay, here, the x-axis here. So at x-axis, y is equal to 0, yeah? Therefore, y bar 1 and y bar 2 both equal to 0. Okay? Y bar 1, no, equal to y bar 2 equal to 0. Therefore, we have m2 y2 equal to 0 and m1 y1 equal to 0. Okay. When m1 y1 m2 y2 equal to 0, we also cancel the m1 m2 here. So we have y bar equal to m3 y3 over m3. Okay, that is the solution for this. Okay, now let's see what centroid means. Centroid ignores width and consider only volume. Just now we talked about center of gravity. The word is center and gravity. When gravity comes into picture, mass or weight also will come into picture. Okay, so this centroid, unlike center of gravity, it doesn't include weight or mass at all. It only consider volume. Yeah, so it only considers the geometry. Okay. Different densities of material, the center of gravity and centroid do not always coincide. Okay, if you have a composite object, yeah, when we say composite, an object is composite, it means one, it could have different geometrical dimension, or second, it could be consist from it could consist different materials. Okay, in other words, it is not homogeneous. Okay, homogeneous, on the other hand, is an object which is made of similar materials throughout. When this happens, when the material is homogeneous, the center of gravity and centroid has a possibility to be coincide. That means to be on the same spot. Okay. Type of centroid, we have centroid of lines, because we deal with rope, wire, etc. Yeah? So we need to find the centroid of lines. Centroid of lines is easy. If you have 1 meter rope or 1 meter length of wire, the centroid is taken as L over 2. So 1 meter divided by 2 will give you 500 centimeters. Ya ke? No, 500 millimeters. Okay. Centroid of areas, we have to find the X bar and Y bar. Centroid of lines just now is the line is in the x-axis, you have to find the X bar only. If the line is in y-axis, you have to find the Y bar only. But when it comes to an object with an area, you need to find both X bar and Y bar. The term area could be simple area or composite area. Just now I mentioned composite means either it has several different or various areas, or it is made of several or different materials. Okay. Now, example for simple areas. Okay. This rectangle is an example of simple area. Example of composite area. Okay, this is an example of composite area, the T now. Okay, for example, when we deal with beam rasuk, yeah, we could have rectangle beam, we could also have T-beam, we could have I-beam. For column, we could have rectangle, we could have circular, we could have T column, we could have H column. Okay, so this rectangle is an example of simple area, whereas this T is an example of composite area. If we have 3D, this figure that I draw just now is in 2D. Yeah? If we have 3D problem, we have to find X bar, Y bar, and Z bar. Okay, now let's look at Centroid offline. Okay, for one dimension objects such as rope, rope, for example, is an example of a one dimension object. Yeah. When the engineer use software analysis or analysis software or design software, we have so many. Yeah, in industry. You will learn later in the next semesters software like StatPro and certain other for other subject other than structure. Yeah. For example, if you're using software analysis or software design, you want to design a concrete with reinforcement, and you can choose whether you want to design or analyze an object in 2D or in 3D. If you're using 2D, for example, you want to analyze the beam behavior under dynamic load, for example. You want to first model the beam with the reinforcement inside the beam. So if you're using 2D or 3D, you can assign the reinforcement as a line, as a line. When line, it is in one dimension. Anything in one dimension, we treat it as line. Examples are rope, wire, and cable. Okay. Again, when it is line, the centroid is taken as the length over 2. The curved object, the center of gravity is not located in the object and can be determined using formula of derivation. Okay, if you come across a curve line, the center of gravity may not be like donut just now, yeah, may not be or may not located on the object itself, but it is outside the object's body, but it can be determined using derivation. In general, the centroid X bar and Y bar can be determined by X bar equal to summation of XL divided by summation of L, and Y bar equal to summation of YL divided by summation of L. The centroid of line, whether straight, curve, or composite line, can only be determined if the elements are connected and made up from a homogeneous material. Okay, so you have to remember the formula X bar equal to XL summation divided by total L can only be applied when the rope or the wire is made of homogeneous material. For the straight line, the centroid lies at the distance L over 2 from reference axis. Normally, the centroid of line is always coincides with the center of gravity. So for one dimensional, for rope, for line, the centroid of line is always coincides with the center of gravity. Now let's look the first example. Determine the centroid of a thin homogeneous wire. The thin homogeneous wire which made up a triangle here. Okay, made up a triangle here. Okay, the AB, the length of AB is 600 millimeters. The length of AC is 250 millimeters. The diagonal length of BC is 650 millimeters. So the line AB, its centroid is at 300 millimeter, okay, at the dotted line here. the y-axis AC, line AC, the y bar now is 250 divided by 2, 125 millimeter, represented by the horizontal dotted line here. Okay. Okay. The centroid, if you are familiar, if you are an engineer, you have to know that the centroid is somewhere here. Is somewhere here. This is where the centroid is. Okay. How to find the centroid? It is so easy to find, especially when we use a table like this. Okay. The table should include the parts of the area. No, we don't consider the area now, parts of line, yeah, or we can name it as segment. We have segment or line AB, we have segment or line BC, we also have line or segment AC. Okay, AC, AB, BC, not CD, AC here. This is AC here. Okay, AC. Now AB, the length is 600. So the X bar is 300. 300, yeah. The Y bar is 0. Why is the Y bar 0? Again, because the Y bar, the AB now is on the X axis. That means the X axis now is here. Okay, this is the X axis. And this is the Y axis. At X axis, coming back to AB just now, segment AB, at X-axis, the Y bar is 0. That's why we put 0 here. Okay. Now let's continue to the diagonal line BC. The diagonal length BC, we have total length 650. The X bar, now the X bar is 300. And the Y bar now is 250 divided by 2, we have 125. Okay, 125 millimeters. Okay, and finally the segment AC, we have total length 250, and we have X bar now equal to 0 because X bar now is on the Y axis, so X bar is 0. The Y bar is 125 millimeters. Sorry. Okay, 125 millimeters. So let's look at the formula here. To find the X bar, we need to find the summation of XL. So first we find the X times L. X times L gives us 18 times 10 to the power of 4 millimeters square. XL for the second row now is 19.5. 10 to the power of 4, and XL for AC, row 3, we have 250 times 0, we get 0. In a similar manner, we can fill the rows for Y bar L, okay? Then refer back to the formula. We need to find the summation of XL and summation of YL. So summation of XL, we plus 18 with 19.5 with 0, we get 37.5 times 10 to the power of 4. For summation of YL, we add all these, we get 11.25 times 10 to the power of 4. Okay. Uh, to find the x bar, we have to divide the summation of XL, 37.5 times 10 to the power of 4, with summation of L. Summation of L is the total of line AB, BC, and AC. We add all this up, we get 1,500. So we divide this value with 1,500, we get 250 mm. The X bar now is 250 mm. In a similar manner, we get the Y bar equal to 75 mm. Now let's draw where